Assalamualaikum and greetings. In this video, we're going to look at the halogenation reaction for alkenes. At the same time, we're going to discuss the free radical substitution that happen in this reaction. We're going to start off with the alkene. In general, all the carbon chain will be represented by R. And we only require one hydrogen from the alkene compound. We're going to react the alkane with a halogen compound. Doesn't matter, it is chlorine, bromine, iodine, and so on, which is written in general as X2, or you can write it as XX. This reaction will produce a substitution of the hydrogen with the halogen. So we're going to get R, X, and the side product of HX. In general, if we have a methane compound such as C, H, 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 and H reacted with the chlorine, what we're going to get is the chlorine will attack any of the hydrogen here. So for instance, it will become C, H, 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 and one of the hydrogen will be replaced by Cl from the chlorine and the side product of HCl. The process will continue if we add another more chlorine molecules. Okay, for instance, if we add more chlorine, so what will happen is the structure will become like this: C, H, H. This is the initial chlorine, and this is the new chlorine that has been inserted with the side product of HCl. This process will always continue until there is no more hydrogen to be replaced. In another example, if we have a compound, we're going to react this with bromine. Under the presence of heat or UV light, the bromine will replace either the hydrogen from the primary carbon, the secondary carbon, or the tertiary carbon which contain hydrogen. So there is 4 points that we can use to replace the halogen. So the product will be looking like this. Or it can be also like this. Or it can also be like this. There is also other possibilities that the product can form. It can also replace the hydrogen from here, and any available hydrogen. Among the three products, the most stable compound will be the second one, since the compound will form a more stable radical at the tertiary carbon compared to the primary or compared to the secondary carbon. Now we're going to look at the mechanism that happens during the halogenation reaction. For instance, if we take butane, which we're going to react with chlorine, under the presence of heat, so one of the product that will come out is 2-chlorobutane. The side product of HCl. The compound that can also be obtained is 1-chlorobutane. However, based on our discussion earlier, the secondary carbon will form or more stable free radicals. The mechanism involves 3 steps. It is initiation, propagation, and termination. For the first steps, which is being called as initiation, it only involves the chlorine, where we have the chlorine molecule Cl, Cl, and when it is being heated, it's going to undergo the homolytic fusion, and as you can see here, the bond over here is consisted of 2 electrons. The homolytic fusion will make the chlorine obtain 1 electron each, and it's going to produce Cl radical plus Cl radical. The next step is the propagation. When we obtain the chlorine radicals, it's going to further react with the butane molecules. So based on the equation, the chlorine will replace the hydrogen from the second carbon. The carbon and the hydrogen also consist of a covalent bond which have 2 electrons in it. The chlorine will attack the electron, resulting to the formation of HCl. The side product will be a butane radical. This process will continue where the butane radical will attack the chlorine molecules, which is Cl2. I just write that as ClCl. Again, it consists of a covalent bond which have 2 electrons in it. The butane radical will attack one of the radical of the chlorine to produce 2-chlorobutane plus Cl radical. In summary, the propagation reaction involves a radical together with a neutral compound. The final step of this mechanism is being called as termination. In this step, only the radicals will react with each other. So there are 2 radicals that has been produced. First one is chlorine radical. The other one will be butane radicals. The chlorine radicals will react with another chlorine radicals to form the chlorine molecules. The butane radical will also react with chlorine radicals to form 2-chlorobutane, and another combination when we have butane radicals which reacted with butane radicals to produce different compounds. So there you have it. This is the free radical substitution by Alkane under the halogenation reactions. In summary, there will be 3 steps that you should know. First one is the initiation, which only involves the chlorine. Propagation, which involves the radical with the neutral compound. And finally, the termination, where we have radicals reacted with one another. Again, this reaction will proceed until all of the hydrogen has been replaced by the halogen. See you guys in another video. Thank you.